Okay, pre-calc, I just want to give you another example. If the camera goes out of focus, it'll refocus for us. Okay, so let's try again. Let me just make up something that's more on a pre-calc level. Okay, this looks great. So this is a cube function. If I just draw this real quick for you, this is shifted up 1 unit. We did graphing yesterday, so you should know that this is outside of the house. So this moves it up 1 unit, so it's centered here, and it looks like this. And we know that this passes both the vertical and the horizontal, so this function does indeed have an inverse. So let's go through the steps again. So remember, first what you want to do is replace f with y. Okay, then, which is the most important step, is next. You want to swap x and y. This is the most important step right here. You're swapping x and y. Now I'm going to isolate y. So I'm going to move the x over. And I need to get the y by itself, so I have to take the cube root here. So this is the inverse. Okay, this is the inverse right here. If I make some effort to draw both of them, so I'll draw this nicer this time. The original f is up 1, so it's got the point 0, 1. It also has an x-intercept if you solve that out at -1, 0. And let me just put a point over here so you can see if you put in a 1, it will be a 2. Okay, so this is the original, this is f of x, and you guys know from the previous video that I did, if you swap the points, that would be on the inverse. So like for instance, if you take 0, 1 and you swap it, that will be 1, 0. If you take 1, 2 and you swap it, that will be 2, 1. Right? If you take this point and you swap it, that would be 2, 1. If you take this point and you swap it, that will be -1, 0. You also need to combine with the concept that the function flips over this line, y equals x, right? We talked about that. It flips over this line, y equals x. So now I have to make this, if it helps you, just think that you're going to make this look like a mirror of the original. So for instance, here, this part here, this guy has to flip over to this side, meaning, you see how I mirrored this? Like these are equidistant from each other. It's got to mirror it. Now this is what we would call concave up. So when I flip it over the line, it's actually going to look what we would call more concave down. It's going to drop water. You gotta love this filmmaking. I'm sorry if occasionally you get a picture of my knee or something in here. You gotta laugh at life. Life has gotten so weird. Alright, this part right here is concave down. So the other part, when it flips over, it'll be concave up. It'll hold water. And then this guy, it's gonna cross here and it's gonna go like that. So just see if you can see, like, it mirrors itself. It mirrors itself. So if you've never seen what a cube root function looks like, it actually looks like this red thing. It's a little bit more, well, it's pretty good actually. It's like an S on its side. But you can see that these mirror each other about the lines. So that's sort of the idea, how you can see the symmetry. Okay, what else do I want to say here? Okay, let's make sure we're good with, oh, the verification. Let me do that with you. Let's verify that f and f inverse are, these two functions are inverses, right? So that goes back to that rule we said before. Okay, I'm just going to do it in the order of this. Again, feel free to do that order too on the test. I'll probably just say it. And let me just move our two functions over as well so I have them. So the first function we had was x cubed plus 1, and the second function we had was And hopefully you made the observation that the negative was under the radical, so therefore it's moving to the right, right? If it's inside, it's left, right. If it's outside, it's up, down. All right, so here we go. Let's do it. So we're going to put F inverse into F where the X is. That's how you do a composite. That's how you substitute in. So the original is something cubed plus 1. I'm putting the inverse into the original. Right, there's my inverse in the original. A cube root and a cube are opposite, so they cancel each other. The -1 and the +1, I'm sorry, my knee seems to want to be the star in the show. The -1 and the +1 cancel each other, and you get X. Okay, all right, let's do just a quick wrap up to make sure we're all on the same page. All right, 1.9, what kind of things am I going to ask you here? All right, so for 15 and 17, when it says that verify them algebraically, what that is asking is what I just did at the end. That's what I just did at the end. You're going to take their composite. You could just do it one way. You don't have to do it both ways. You don't have to do it both ways. Just pick one way and do it. So this means for this one, just take their composites and make sure that they equal to X. Okay, that's those two that I'm going to give 15 and 17. Now let's see what this one says. Use the graph of the function to sketch the graph of the inverse. Okay, so what you can do is you can find a couple points on here and then just swap them. So like for instance, if you have the point 0, 1, then you must have the point what? 1, 0, right? And so you could grab another point on here if you want. It looks like maybe you have the point, I don't know, even if you estimate it, it's fine. I don't know if you have the point 43, or if you estimate it, you'll get it enough in the ballpark. Okay, so that one you just flip the points and draw the picture. I'm going to give you, let's see, 23, 25, 27, algebraically and graphically. Okay, so you're going to do both steps on these like I just did before. You're going to algebraically show they're the inverse, and then you're going to graph them. Okay, hold on. That's starting to feel like it's too many problems. Hold on. Let me take some off. I know I'm giving... this class goes so fast. Okay, since you're verifying these over here, let's not overkill on the verifying. That's too much verifying. We'll have you verify on these. All right, so I'll do this one. I'll just have you verify on these. You don't need to do 5 verifications. That's too many. Okay, here you're just going to do the horizontal and the vertical line test on these two. Okay, and these are test level, because this is how I would have it done on a test. I'd give you the function, you find the inverse. So I give you 57, 61, 69, and is there no cube root anywhere? Okay, I guess over there. All right, and these. Now here, what you need to do first is find the inverses. So you first find the inverses, and then you take their composite, and then you have to make sure you let x equal to 1 in the substitution. Okay? Here, this is different. Here, right, you have to first take the composite and then find the inverse of the composite. So you may have to, like, wind back this video to make sure you got it at the end. Okay, gang, so that's the homework. Again, I'm going to just start you at 19. This is more than enough work, these couple of examples. All right, that's it for lecture today. I hope you guys are good. Catch you again soon. Bye-bye.